Morning, everyone. Thanks for making it here, especially after last night. Good. So my name is Gerry Miller. I'm the chief technologist with CloudHSM. Let's see, where's my clicker here? So when I was growing up, this is what computers looked like. That's what I remember. Telephones had cords and rotary dials, and doctors actually made house calls. Lots changed since then. So what we're seeing today is sort of this convergence of lots of things changing. All sorts of technological advances, almost limitless storage. We've got ubiquitous connectivity, all sorts of advances in medical devices, coupled with all sorts of interesting changes in healthcare regulations, in patient expectations, in our lifespans, and our general health. And especially as we move into 2014, we're going to talk about some significant regulatory changes that are coming forward that are really forcing a real difference in how we deliver healthcare and how technology plays into that. Like I said, my company's CloudHSM. We focus exclusively on delivering HIPAA-compliant applications on the AWS cloud. And I'm going to talk to you today about a project that we did for Spectrum Health in Grand Rapids, Michigan. We built a healthcare portal for patient access directly into their medical records. We're going to talk about the reasons why Spectrum undertook this project in the first place. We're going to talk about some of the business and regulatory drivers that led to the project. And then we're going to do a deep dive into some of the technical solutions. So we're going to cover sort of the range, everything from the high-level stuff all the way down into some of the guts of the solution that we developed. Now, at CloudHSM, we're pretty proud of the work that we did, and I'd like to stand up here and kind of brag about it for you. But instead, I don't think there's any better person to tell you about this project than the customer themselves. So I'd like to invite up Mark-Welscott, who's a director at Spectrum Health, to talk about this project.
Thanks, Gerry. And what I'd like to do today is really just set the context to hand it back off to Gerry and Keith. Tell you a little bit about Spectrum Health and why we went down this path. Spectrum Health is an integrated delivery system. We're based in Grand Rapids, Michigan. In our hospital group, we've got about 11 hospitals, or we have 11 hospitals. In our medical group, we're approaching 800 physicians. And in our insurance group, we cover over 500,000 members. On the delivery side, we see about a million patients a year. And we've got about 20,000 employees. So that may give you a sense of the size of Spectrum Health. As most healthcare organizations are dealing with healthcare reform, we're no different. So one of our key drivers, especially on the delivery side, is meaningful use. Many of you, if you're in the healthcare field, know about meaningful use. It's part of the healthcare reform where the government is trying to incentivize healthcare systems to leverage their electronic medical record. This is both at the physician level as well as the patient level. What you see in the regulations is this is kind of a carrot and stick approach. The carrot is, for the first few years, the healthcare system can receive significant amount of incentive payments if they meet certain metrics. The stick approach is if you don't meet those metrics in a couple of years, they will dock your reimbursement. For Spectrum Health, we've calculated this in the millions of dollars of impact for our organization. So one of our key strategies to meet meaningful use is our patient portal. Today we've got a patient portal that's a vendor-based system. It's very rigid, and it has a lot of limitations that are hampering us from hitting those meaningful use metrics, or we're anticipating that. There's two areas that we are really focused on with our patient portal. One is integration. We've got several different medical record systems across our enterprise, and that patient portal needs to interact and get data from all of those. So integration is a big key. Patient experience is another key for us. Innovating around patient engagement, patient experience. We don't feel like we can hit those metrics for meaningful use without having an engaged patient. So as we looked at our options around the patient portal and patient engagement, we looked at, will our current solution get us to meaningful use? And the answer there that we came up with was no. So we really needed to go out and see what other options that we had. We landed at building a custom solution. And this was a little bit of a stretch for us. We felt that in order to differentiate Spectrum Health in the marketplace, we really needed to innovate around the patient experience. So I had three main concerns when we chose the custom path. One was this innovation and patient engagement, and could my team react fast enough to innovate and hit those metrics. The second was time to market, and the third was security. So around the innovation side of it, we partnered with Keith's group, Keith Brophy at Ideomed, who had a long history about patient engagement and creative and innovative ways to do patient engagement. We also, for the time to market piece, this is really where the cloud came in for us. We didn't know what we needed at the time. We had a very short time frame to get a solution up and running, and not just to production, but I needed to get a development team up and running very, very quickly. So rather than going through my corporate IT department and securing all of the resources, and at the time, I didn't even know what we needed for this development effort. So the cloud seemed like a natural fit. AWS was then selected as that vendor, and Keith will talk a little bit more about that too. And the last concern that I had really was around security. For those of you in healthcare, patient data is like this sacred thing. You can't mess with the patient's data. So putting this out into the cloud, we had two challenges there. One was the technical challenge. That's where Gerry will talk about in a little bit. And the other was a cultural challenge that we had. People are scared in our organization. We've been around for years and years. Putting data into the cloud is a scary, scary thing for them. So, with Gerry and Keith and I, we were able to achieve those cultural barriers in addition to the technical things that Gerry talked about. So I hope that gives you a brief context of Spectrum Health, what we were trying to achieve. And at this point, I'd like to introduce Keith Brophy, who is our innovation partner on this project.
Thank you, Mark. Mark's painted a great picture of the backdrop for our step forward with the customized Spectrum My Health solution. The healthcare experience of the future launched in 2013. It presented an interesting opportunity and challenge, an opportunity to connect very closely with our patient base, but the challenge of how do you build the trust that's required of an effective digital experience, a doctor-patient relationship through online interactions. There is three layers to the ultimate patient experience that we identified at the outset. Of course, there's the user interface that must be simple and engaging. And then there's the function surfaced by the online experience. And then there's the under-the-hood part of the system, the infrastructure ecosystem that has to provide the foundation of security and reliability and availability. And we knew that all three of these layers, the user interface, the function, and the under-the-hood infrastructure, were going to be critical in the way that they came together to form the solution. So I'm going to provide you with a whirlwind tour of a couple of slices of user interface and function and make some comments on how that mapped to what was under the hood and what our requirements were for the under-the-hood infrastructure. And then we'll segue into Gerry talking in detail about what we turned to and how we achieved the ultimate system in our view. The patient experience really starts at enrollment. And enrollment is a classic example of a failure is not an option scenario. There's been a couple decades now of industry research that shows if a user goes to enroll and they hit a glitch or it just takes too long, they'll abandon the effort and likely never come back. It's been very amazing as we've heard the talk about the healthcare.gov, the Obamacare portal, about some of the challenges, but also I've heard expectations that it's all okay as the system is eventually brought up to speed, but that doesn't match with the realities of research. If somebody has a bad enrollment experience on an online system, a good share abandon the effort for forever or for years. So this experience was very key. We knew it had to be simple, intuitive. It had to serve specific function. We do certain validations of the user when they enroll. And it also had to be immediately available, high performance, and reliable. Oops, sorry, a little sequence here. All right, thank you for bearing with me. As we continue on our journey here, another element of the solution was lab results. It was imperative that patients could view their lab results and see reliable data that corresponded to their tests. This is kind of the ultimate of the trust relationship. It's important that they can get to their information and that they can get to it quickly and that the data is their own data. The under the hood elements of this aspect of the solution map to, among other things, security. This solution had to provide high protection of individual data and align with the HIPAA regulations on protection of healthcare information. So we needed an infrastructure that would give us the capability to build in the epitome of security. Timeline is another key element of the solution. The timeline for My Health surfaces the flow of events and activity that the patient experiences. And this is an important aspect of the whole concept of patient engagement with a digital experience. We want them to have clarity into their relation with the healthcare system. And by surfacing the flow of their interactions, it provides clarity and confidence. Under the hood, it introduces a challenge because this timeline of information comes from multiple sources, multiple integrated systems, including 2 different electronic medical record systems, among others. So we had to build in that convergence under the hood, but at the user interface layer, let the patient experience is just one transparent flow of their timeline. We needed an infrastructure that would allow us to build in that convergence in a highly responsive, high-performance manner. Appointments is another very key element of the solution. And I wanted to share a healthcare challenge that those of you that are not close to healthcare may or may not realize this healthcare appointment quandary, but there's a high percentage of patients that never quite get around to scheduling that appointment that they need to schedule. And then there's another high percentage of patients that once they schedule that appointment, they never quite show up to it. It's a national healthcare challenge. So we wanted to streamline the appointment process, allow the user to easily make an appointment right online, and to be reminded of that appointment. So a simple user interface was again key. Reminders, we have a mobile solution that parallels this online web solution, and we send out push notifications to the patients right on their mobile device. And we also knew that just as in enrollment, with an appointment scheduling, the stakes are so high. Appointment scheduling tends to be a human procrastination activity. And if you click that button and there's a couple seconds of delay, it can cause the patient to do a U-turn and abandon the effort to never return back to that appointment. So this feature also is a classic example of high reliability, high availability. It has to be a successful interaction every time out. Here you see our lab result details, the user interface surfacing of lab results, and the user interface experience that wraps around it. And here you see the medication surfacing for the system. The medication feature of the MyHealth solution shows not only prescribed medications, but medications that the patient might add on their own, including supplements or non-prescription medications. And this is another example of the high bar of trust. When it's your medications, if you're turning to the digital experience to affirm what your medications are, or to double check on a name, that information better be there when you need it. That information also needs to be unquestionably secure. It was interesting, in another parallel to healthcare.gov, is there is some talk about initially in the early rollout, some healthcare.gov users getting information that wasn't their information initially. And one of the refrains that was offered in the media about that was it wasn't critical data. Our solution is in a different realm. Every single aspect of MyHealth is vitally critical. There's not one piece of our solution that's not extremely critical data. It's so critical that that critical protection of data even includes to those that work on the system. We had to address issues like developer access to the data as well as general public access. So we needed an infrastructure that would allow us to be HIPAA compliant, protect every aspect of the data in this solution. What we did is we looked to this blend of user interface and function and under the hood capability. Is we didn't look at those as just distinct layers. We looked at how they come together. And so our choice of the infrastructure was essential for the success of this initiative. That choice is we looked for performance, availability, reliability, security, led us to AWS. And one of the other overarching elements that led us to AWS was flexibility. No system freezes in time, and if there's one thing we know about healthcare, it's transforming. We know that MyHealth will continue to evolve. So we needed an infrastructure layer that was extremely flexible as well. Gerry Miller is going to return to talk about that AWS selection and the details of what's under the hood. Gerry?
Thanks, Keith. So again, Gerry Miller, Chief Technology Guy with CloudHSM. Let's talk about how we solved some of the challenges that Mark and Keith laid out. I'm going to talk about the three big ways, the three big problems that we tried to attack. I'm going to talk about some very specific and detailed technology that we employed to solve these problems. And while we're talking about this, we'll sort of lay out what the architecture of the system looks like. So the first big problem we had to solve was data protection. We had to have encryption everywhere, in transit, at rest, in databases, files, absolutely everywhere. And we had to encrypt in such a way, HIPAA requires NIST compliance, and NIST compliance requires that you keep your encryption keys separate from the encrypted data. So we're going to talk about how we approached that problem, how we solved the problem with AWS technology. Another problem, as Keith mentioned, is we had a number of developers work on this system, and they would come in and out and maybe offshored some pieces. So that meant that a lot of developers had access to not only code, but probably passwords or keys or certificates that allowed direct access to some of these back-end electronic medical record or EMR systems. So we'll talk about how we solved that problem. And finally, we're going to talk about some process improvements that we made that allowed us to automate every aspect from building the code to deploying the code to deploying QA, staging, and eventually production environments. Now, the reason that we had to automate all of that is because any time a human being is touching a keyboard, a mistake is going to happen. And we just could not take any chances at all that any mistake was made that would compromise the integrity of our patients' data. Keith mentioned the word trust. Our patients trust Spectrum Health with their most intimate personal details. And in turn, Spectrum trusts Ideomed, CloudHSM, and ultimately AWS to be strong stewards of that information. We took that seriously and built in that level of trust from day one. So let's dive in and talk specifically about how we did that. So first, I'm going to give you sort of an overview of how the application is built, both from a conceptual standpoint and then from a physical standpoint. And then we'll dive into some real detailed areas of the solution. So MyHealth is both a web-based application. For those of you who are developers, it's a single-page app. Our front end is written using AngularJS framework. We make AJAX calls using REST to a back-end RESTful services layer that then uses very secure SOAP, WS security secured calls with certificates directly into a service bus that accesses the back-end EMRs. We have multiple EMRs, multiple sources of data, so we do a lot of data aggregation and sorting so we can present unified views of information back to the client without having to pull that from a single source. All of this happens in real time, highly performant, needs to scale dramatically, but yet not cost too much at any given time. We also call external services. For example, there's an RSA service that allows us to validate identity by asking certain questions. So that's the conceptual architecture. We laid it out on AWS like this. Everything is in a virtual private cloud, or VPC. That's a requirement. We have private addressing inside that VPC that aligns with the internal addressing scheme at Spectrum Health. We have multiple redundant VPN connections between AWS and Spectrum Health so that we've got redundant tunnels. If anything goes down, if a router goes down, if the VPN drops for whatever reason, we've got multiple redundant routing. We've got, if you notice, multiple layers. We've got a development layer and a test layer and a staging layer and a production layer. The development layer is a single server, but everything else mirrors production exactly. So what we're testing, what we're staging, what we're eventually pushing to production is an exact mirror of what will eventually go to production. We made sure that we load balance everything and that we span availability zones. So the load balancer pushes to web servers that sit in multiple availability zones. So if there's a problem in any given AZ, we are almost immune to that failure. And while it doesn't happen often, we have seen that happen, and we did see that our system experienced zero downtime. We have employed elastic load balancing and auto-scaling so that we have a minimum of, at any given time, of 2 web servers and 2 RESTful services layer servers. But if we experience greater demand at any of those layers, we will automatically scale up and then scale back down when it's no longer necessary. We'll talk a little bit more about where you see CloudHSM. I'm going to dive into detail there, but that's our encryption solution, and we'll go into some more detail about that. We locally use SQL Server to store it, so we built a SQL Server 2012 always-on availability group cluster, which is, again, spans multiple availability zones. We'll talk about how we encrypted that, and then all the way at the back end of that, we reach out into Spectrum's internal systems. So that's the physical layout and how we leverage the infrastructure available on AWS to deploy the solution. Now, we have web browser or mobile client calling through a bunch of layers that eventually hits the EMR, the actual EMR. So this was the part. Mark mentioned getting past the culture, because that's a scary thing. You know, we've got a lot of layers, but ultimately, the internet is full of nasty things, creatures and bugs and viruses and people that want to do bad things and access data that they shouldn't access. So let's talk a little bit about how we layered security, because the best way to build a good security system is by layering. You can have a single layer, but if you add layers and layers and layers of security, each time you multiply how secure your system is. So in this context of a big, bad world, we first come from the internet, and we come into the web servers. So here are the layers of security that we have available to us already at the web server. And the web servers, by the way, have no access to any layer beyond them. Just the web servers can only access the RESTful services layer, and only that can access the internal system. So layered security. We come in, there's an Amazon perimeter that takes care of things like DDoS, or distributed denial of service attacks. Then we've got a set of routing rules. If any of you have worked with the VPC, the ability to define routing is incredibly tight. Then we have a whole set of ACLs and security groups. Then we've got the firewall on the Windows servers themselves. Then we've got the ability to apply ACLs at the file level on Windows Server. So already, by the time you get to the web server, we've sort of stamped out a lot of these bugs, right? Now, we then are able to layer that whole thing again using the same set of technologies before we hit the RESTful services layer, which sits in a different subnet in the VPC, and so we can apply the right rules at that level. So we split this thing out in multiple subnets, closely and very tightly controlled what can access what can access the internet, what can access each other. Then we reach into the spectrum layer, where we are able to apply even more. So if you see the number of points of opportunity to specifically address your security layer, it's a really effective way of stamping out all the nasties that exist on the internet. So now that we talked about the general architecture, let's go into some of the specifics. One of the first things we did was try to research how we were able to affect encryption without keeping the keys with the encrypted data. That's a hard problem to solve. So for example, we do use S3 storage, and S3 does have the AES 256-bit encryption option, but we couldn't use it because those keys are accessible inside of the Amazon cloud to Amazon personnel, just as the encrypted data are. So while we were struggling to find a solution for this, right in the middle of that struggle, Amazon announced the availability of the AWS CloudHSM. Now, for those unfamiliar with this offering, CloudHSM is an actual physical appliance that Amazon houses at the AWS data center. It is dedicated, each appliance is dedicated to you. It sits in your VPC with your VPC address range. The actual device is a SafeNet Luna SA device, which is a very expensive, super high-end, tamper-resistant security device. It allows key storage, key management, and it actually does offloaded encryption. It's loaded with GPUs that do like lightning-fast encryption. So we are able to now generate our own keys. While they're stored in the Amazon or the AWS data center, those keys are inaccessible. AWS does not have the administrative passwords to this device, and it's physically tamper-resistant. Everything is stored on flash memory, and if somebody tries to open the box, it erases itself. So this was a great solution. Now, if you notice, there are two HSMs in line with our philosophy of redundancy and high availability and no single point of failure should something go down. We actually deployed two of these, again in separate availability zones, and configured any client that accesses these to work in a high availability mode. So not only does it load balance between the two so that no one HSM is more active than the other, but should one go down, and to be honest, we had it a few times where one went down, we saw zero downtime again. The system failed over instantly and then went back to regular HA mode as soon as the device became available again. So what did we encrypt with the CloudHSM? There are three main places where we're storing data locally before we hit the EMR. The first is in our databases. We were able to configure transparent data encryption, and I'll explain how that works a little bit more detail in the next slide. But we configured it so that the data, when the database server, SQL server, persists the data to disk, that data is automatically encrypted. We'll go into some more detail on that. The other place is files. Files for us, we can do anything from, we might be delivering to a patient their medical documents, a document called a CCDA, which is an XML representation of their entire medical record. That will persist to S3, and obviously that needs to be encrypted. We also accept uploads. Somebody might take a photo of a spot on their toe and upload it in a message to their doctor and say, hey, can you look at this? What does it look like? Those data, too, when we upload it, we temporarily persist it to EBS, and then we permanently persist it to S3. So in both places, we use the CloudHSM device to encrypt that. So SSL traffic, encryption in transit, CloudHSM, encryption at rest. Nowhere do we ever ever, even ephemerally persist unencrypted data, ever. And it's always done through the CloudHSM device, so we're always NIST compliant, therefore we're HIPAA compliant. So the TDE is kind of cool. You know, one thing that Mark talked about was that one of his critical success factors was developer agility. We needed to build the system and deliver it at light speed. So while, you know, high security is often a trade-off of convenience, right, versus security. So the more secure your passwords are, the harder they are to remember. It's hard to change them all the time. You know, you got to unlock your phone every time and type the PIN in or whatever. It's a pain, right? So we recognized that there was a good chance that all of this advanced security we put in would require developers to kind of jump through hoops and possibly slow down the development environment. That was something that security was first. Under no circumstance would we compromise security, but we worked really hard to find ways to implement bulletproof security in a way that would not hamper development. So, for example, with accessing databases, we needed to encrypt the data that was persisted to disk, but we wanted to do it in such a way that did not change the way that developers work with databases. Our code was written in Microsoft.NET, so we were using the .NET classes to persist data to databases, and we didn't want to change the way that developers worked with things, the way that they knew. We didn't want to slow them down. So we turned to transparent data encryption, which is a configuration that's supported on many databases, SQL Server included, that allows you to configure the database such that the database takes care of encrypting the data before it persists it. And that's done transparently to any developer. You don't work with the database any differently. Now, the problem with TDE, or transparent data encryption, is that the standard way of doing it stores the encryption keys in the database. Now, here you have keys with encrypted data, not good. So we turn to, you notice in the lower right corner there, it says EKM. That's an external key manager. So we configured CloudHSM as an external key manager, and now SQL Server transparently, once it's configured, it's kind of a set and forget thing, not only stores the keys in the CloudHSM device, but actually offloads the encryption and decryption process to the CloudHSM device, which performs those operations an order of magnitude faster than it would happen on the machine itself. So that was how we secured our databases via transparent data encryption. The configuration of that itself, pretty simple. It's just some SQL. Here's a little excerpt. It's not the whole SQL script, but you know, we just configure the external key manager module. There's just a DLL. You encrypt the databases, load it up. Interesting making that work with the always-on availability groups, but we kind of banged our way through that. And once it was set, literally set and forget, we're fully compliant. Developers don't have to worry about anything. There's very little care and feeding to this solution. It just works. The next thing we had to address was we have configuration files that contain all of the sensitive keys, like to access our back-end EMRs, to access the service bus, you know, all of the certificates and that sort of thing. So those files and those configuration settings need to be accessible to developers because when they're writing their code, they have to be able to test it, right? But we were worried that what if a developer has that and goes off the project and perhaps shares that or even uses it maliciously? So we had a quandary. How do we give developers access to the systems and the configuration information that they need to get their job done without slowing them down, but yet kind of shield them from being able to carry that with them or use it in any malicious manner? So what we came up with there, again, CloudHSM based, in .NET, as in most languages, access to configuration files is done through a central set of resources. And the .NET framework actually provides a whole set of functions that you can call as a developer that sort of centrally manage access to configuration files. As it turns out, you can sort of write your own driver that the .NET framework will just use if you configure it to do so. So we wrote what's called a custom protected configuration provider that allowed us to take an unencrypted configuration file that contains, you guys can take a picture of this, I changed the keys. So it allows you to take all of this super, super secret information that your developers really need. I mean, they can't do their job without this, and turn it into this. So this is what developers see. Transparent to them, again, our goal of not slowing developers down. Transparently to them, they write the same code to pull configuration information, but transparently, the .NET framework, because of that custom provider that we wrote, goes to the CloudHSM provider, gets a key, instructs it to do some decryption, and in code gets the decrypted information, but the developers never see that in their source code. Finally, we automated everything. And when I say everything, I mean everything. There's nothing manual about what we do. And I'm going to take you through some pretty interesting things that we did and some hoops we jumped through, some difficulties we encountered, and ultimately the solution that we came upon. We made sure that all of our builds and our deployments were fully automated. I'll talk about that. We made sure that even things like launching instances and load balancers and all of that stuff was automated. Talk about that. And how we maintained redundancy absolutely everywhere with our core tenet of never being unavailable. Patients should always have access to their information regardless of the state of the AWS system. So one thing we did was we automated all of our builds. Here's a picture, actual screenshot of our dashboard. We used cruise control. But you can use Jenkins or Hudson or TeamCity or any automation environment. We fully scripted every single build and deployment. On the front end, that involves a lot of like Node.js stuff with Grunt, and we have gigantic suites of automated unit tests. So the build actually runs every single unit test, an end-to-end test. Builds fail if any unit test fails. Automatic notifications go everywhere. So even the process of building the system, no human, we don't spend our time building. We spend our time writing build scripts so that it becomes a fully automated process that has full governance, full monitoring capability, and no opportunity for human intervention, which often results in human error. We also extensively used AWS CloudFormation. If you're not familiar with CloudFormation, it's a templating system provided by AWS that allows you to describe in a JSON dialect the overall system that you want to deploy. So it allows you in JSON to say something like, well, I want a load balancer in front, and I want it to have this security group, and behind it I want these two web servers with these security groups from these AMIs, and then behind that I want this other load balancer. Fully describe everything that you can do on AWS, you can describe in CloudFormation. So we wrote extensive CloudFormation templates that we use to deploy our environment. So for example, we don't have sort of a stock QA environment built. We spin up entire QA environments as we need them. And we may have one, or there might be two QA groups. One is doing regular QA, and the other is doing a load test or a security scan. So as we need a QA environment, we simply invoke the CloudFormation script, and it deploys an entire QA environment. It spins up the instances. We actually inject startup script into the instances. There's capability of doing that in CloudFormation, that when the instances come up, they then get injected a PowerShell script that lets them reach out to the build server and request that a build gets pushed to them. So there is zero touching of this. You simply execute the script, sit back, and in 5 or 10 minutes, your brand new QA environment is up and running. Now, the flip side to that is we can then shut down entire environments when we no longer need them. And we don't have to remember, well, let's see, this QA had this load balancer and this web server. You simply say to CloudFormation, shut down this stack. And it, on your behalf, deletes all of your resources for you. Another thing we did with CloudFormation is we automatically use that to push things to production. So in the same way that we can create a QA environment, we can create a staging environment, which is our sort of release candidate. And once it's smoke tested, vetted, and approved, going live simply means switching the load balancer to point to that new staging environment. And then if we need to do a rollback, we just switch it back because we don't take the old environment down. So production pushes are no risk because they're non-destructive. When we roll something new out, we don't destroy the old environment until a few days when we're sure it worked. They're very quick, very easy, zero risk. So both Mark and Keith mentioned, this process that we went through to choose AWS. What you see in front of you is a short excerpt of a gigantic matrix that we built. So after a lot of research, we came down to 5 potential hosting providers. AWS was one, I won't tell you the others. But they were very different, like some were colo and some were cloud-based. So we then had to identify a set of criteria that would fairly compare them, sort of apples to apples, which is not easy to do when you're talking about dramatically different hosting environments. So we looked at a set of high-level sort of functionality and requirements: security, governance, reporting, scalability, availability of support and professional services, et cetera. And then we built a set of weighted and scored criteria for each one of those and applied that across all 5 of the cloud vendors. And what came out on top was very clearly AWS, and that was the choice that we went for. So I'm going to tell you about some things that we learned, some kind of surprising things in some ways. Then I'm going to bring Keith up for an announcement, and then Keith, Mark, and I will answer any questions that you might have. So what did we learn in this process? One thing we learned is that there's somewhat of a misconception that if you go to the cloud, you don't really have to manage your stuff as much because AWS is managing it for you. That's not true. I mean, they're managing the hardware and that sort of thing. But we found that we needed to invest more than we may have expected up front into real administrators who would manage this environment. They're still servers. They might be VMs in somebody else's data center, but logistically speaking, they're still servers. So lesson learned is don't make the mistake of thinking that you're going to be able to skimp on administrative resources. As I said, automate everything. Tools like Chef and Puppet and CloudFormation and whatever continuous integration build environment you want, these are your friends. They're critical and essential because if you touch it yourself, if a human touches it, a mistake will be made, data will be breached. It's a simple fact. Monitor. Just like with administration, ongoing monitoring is key. Again, these are still servers. EBS still runs on real spinning disks. So monitoring is key. You want to monitor every aspect of your performance to ensure that you're not incurring any slowdowns or any potential system unavailability. We had a few upside surprises. So if we were to build this in-house, if we needed to rack all of those servers, we would have had to have filled out procurement forms and justifications and gone back and forth and argued about whose department pays the budget. Then we would have had to have done the procurement, which, I don't know, takes 6 weeks, and then somebody's got to unbox the servers and rack them and configure them, and one's always DOA, exactly right. So, at first, everybody was like, wow, you mean if I need a server, I can just spin up an instance and it's there, and if I need another terabyte, I can just spin it up? Which quickly became, oh, okay, I'm going to spin up another server. So we kind of got spoiled. But we did see just an unbelievable agility and velocity. So Mark said one of the key indicators, one of the key outcomes of this had to be a system that came up quickly, that was developed quickly. The AWS environment and its flexibility and the speed of deployment allowed us to build, I mean, this was probably a 3-year project that we pulled off in under a year. So the accelerated capability was unbelievable. However, with all of that ability to just spin things up and down, cannot be without governance because those things do cost money. And if you spin up 100 or 1,000 instances that you don't really kind of need and you forget to turn them down, then the client gets a bill at the end of the month that might surprise them. So while you want to be able to give your development team the flexibility to take advantage of that agility, which will improve their velocity, it also needs to be done in a tempered and managed and monitored fashion so that you don't get some nasty surprises at the end. So With that, I'm going to bring Keith up for a quick announcement, and then Mark will join me on stage with Keith, and we'll take any questions that you have.
Thank you, Gerry. You've heard about the successful Spectrum MyHealth journey, and I just wanted to share one quick affirmation of what we learned about the AWS infrastructure environment in the process, and to share that via means of a press release that Ideomed is releasing today about another solution we have that's a part of Ideomed is a chronic condition management solution that we sell to insurers and health systems nationwide. It's called a Breeze, and it provides care manager connected daily engagement through web and mobile technologies. And in the process of the very deep exposure to AWS through building out MyHealth, we subsequently made the decision to move our entire Breeze chronic condition management product over to AWS as well. So we are happy that Breeze now has a AWS future. The very advantages that we've talked about, agility, velocity, and all the rest apply. So with that affirmation, we'd like to take any questions that you might have.